This is problem 540 from the Power PM practice exam. It says a generating unit is shown in the figure. The three-phase short circuit MVA contribution of G1 for a 230 kV bus fault is most nearly. Okay, so it's asking for the short circuit MVA contribution. This could also be called the fault duty. So there are two equations that I kept in mind when solving this problem. I'll go ahead and write them. Percent Z source is equal to the MVA of the transformer, MVA transformer divided by MVA short circuit, aka the fault duty, what we're trying to calculate in this problem, times 100. Okay, the second equation to keep in mind, the MVA short circuit or fault duty is equal to the primary short circuit amps, so short circuit amps on the primary side, times the MV, the megavolts line to line, times square root of 3. Okay, so let's pretend, let's solve this problem first and pretend that the transformer impedance is negligible. So we would say that the Z source, 23%, is equal to the MVA of the transformer, 933 MVA, divided by MVA short circuit, what we're solving for, times 100. Okay, solving this out, 0.23 is equal to 933 divided by MVA short circuit. MVA short circuit is then equal to 933 divided by 0.23, which will give you 4,057 MVA. Okay, so we know, this is ignoring the transformer impedance, we know our answer is going to be less than 4,057 MVA, so that already eliminates answer choice D, which is 6,220. When we take into account the transformer impedance, this value is going to be lower. So let's go back and include the transformer impedance. So let's first calculate the primary short circuit amps. We'll select a S base, power base. So S base is equal to the generator three-phase power, 834 MVA. Okay, V base is equal to 22 kV, or the primary side voltage line to line. And then I base, we can calculate I base, which is equal to S base divided by the square root of 3 times the V base, which is equal to 21,887 amps. Okay, we have the transformer impedance as 0.15 per unit, but that is given based on the power of the transformer, 933 MVA, so we need to take this to our base power of 834, and we use the equation Z new is equal to the impedance given, 0.15 times the voltage base old divided by the voltage base new. That's just going to be our 22 kV divided by 22 kV. It's going to be 1 squared. We're not changing, or our base voltage is the same as the voltage we're calculating our primary side short circuit current at, so it's the same. And then multiply that by S base new divided by S base old. So S base new is our generator power, 834. Divide that by transformer power, 933. And you will get a new value of 0.134 per unit. Sorry, I read that really sloppy. Okay. I'm going to write these over here. Z new is equal to 0.1. I base is equal to 21887. Alright, erase this. Okay, now that we've got the new impedance value, let's draw an equivalent circuit. The equivalent circuit, you have your generator, the impedance at the generator, impedance of the transformer, and then I'll just draw an open switch representing the fault location. Okay, so we need to calculate a V per unit at the generator. Once again, our actual voltage and our base voltage are the same, so it's just going to be 22 kV divided by 22 kV, which is 1.0 per unit. We have here our impedance of the generator, 0.23, our new impedance 0.134, and now we can calculate our per unit current. This is just going to be 1 divided by Z total, which is 1 divided by 0.364, just 0.134 plus 0.23, and that gives you a value equal, so our I per unit is equal to 2.747. Okay, so to get our primary short circuit amps, we are just going to multiply our I per unit times our I base to get I actual. So I actual, or I short circuit primary side, is equal to 2.747 times 21,887. That is equal to 60,129 amps. Okay, so that's our primary side short circuit current. Now if we go back to the equation that we wrote down at the beginning, let me erase this equivalent circuit. Okay, so the equation we wrote down at the beginning, MVA short circuit is equal to ISC, short circuit current on the primary side, times V line times square root of 3. And this is MV line. So this is equal to the 60,000, 129 amps times (22 times 10 to the 3 volts) times the square root of 3. If we convert this to megavolts, it will be 22 times 10 to the minus 3. Sorry about that. Times the square root of 3 times the 60,000. So if you do that, it will give you 2290 MVA SC. And you can see that is answer choice B. So that's the answer.